Hello, everyone, and welcome to Jack, Baird, Alberto, Bitar, and myself, Michael Ennis's final presentation on KoBit farms. So here, our issue, or rather the company, and a little bit background on the problem, is that KoBit Farms is a greenhouse growing agricultural business that Alberto and his friend founded in order to help address agricultural inefficiencies in Mexico and the US. They're going to be doing greenhouse growing, which allows them to grow year-round, grow produce year-round. So the problem is that they need efficient transportation routes to the US because their greenhouses will be located in Mexico. And so the different types of produce are going to have varying spoilage times, and they need the most effective routes to deliver produce to different sites without any of them going bad. So the focus will be on exporting tomatoes, strawberries, and spinach because those are the main fruits that they'll be growing initially. Additionally, some other kind of constraints that we have in our model are that each truck has a carrying capacity of only 45,000 pounds. And we also want to try and find the most efficient manner to deliver each produce to each market as well. So here we're going to have the main our KoBit Farms will have the main hub located in southern Chihuahua. And we're planning on exporting to 9 markets across the US West Coast and Midwest. And with that, we will go to the spreadsheet. And here's our spreadsheet. So here we have our cover sheet, which this will display once we run solver. This will display all of the optimized routes as well as the amount of produce to load on each truck. So the first thing you're going to want to do is go to the distances and constraints tab. So on here, we have a grid showing all the travel locations because we used a network LP to formulate the best routes. So we use this grid to index based off of each location. Here's a table of our indices of location. And we had the facility set as origin. We modeled the facility as being a stop, but in reality, when it goes back to the factory, it's resetting the spoilage time, which is the same as if we sent 2 trucks in the first place. So that's why we modeled the facility as 10 here. Additionally, you can click this to add a new market column and row, and then you'll have to type in the location of the market in this table as well, and then that'll allow you to add the new area. However, there is a limitation in this factor in that you have to relook up the travel distance for each facility when you added a new market. So next we'll go to produce orders, and here it's prompting us to put in what the carrying capacity is for the trucks. There's different trucks we're gonna have varying carrying capacity. These are the ones that Alberto and his friend are using. Additionally, we have here the demands for each produce, which Alberto and his friend provided based on their forecasts. And this is the spoilage time and refrigerated driving hours for each fruit. And here we're going to use the minimum spoilage time since each market is giving some fruit to constrain our travel time. Then we're going to go to the optimization. And here our decision variables are located in the age column, highlighted in orange. Here are different constraints for the truck carrying capacity, as well as the truck travel time. So as you can see, it's constrained based on 77 driving hours, which is the lowest spoilage time. And then here, all you have to do is just click Run Solver. And then I will pause the recording as the solver runs. So as you can see here, it has the shortest travel time, which is 133.13 hours. And the solver we ran was a network LP using evolutionary solver intended to minimize the total driving time. And once you've run your solver, if you then travel back to the cover sheet, it now has the optimized truck routes for you, as well as the produce to load. Last quick thing I'll mention are limitations of our model. I already mentioned that you have to add the driving distances if you wanted to add a new market. Additionally, for that new market, you also would need to have the new forecasts for the produce for it. But outside of that, I hope you enjoyed learning a little bit about KoBit farms and greenhouse growing. Thank you so much for listening.